All right. Well, it looks like we're live. Mike, how's it going?
It's going good. How was your week, Dan?
It was pretty good. Got a lot of stuff done, and I'm feeling like the like good kind of tired, And
Yeah, I hear you on that.
yeah, well, I know you and the firmware team have been pushing super hard and delivering a ton of stuff. So felt like great work across the board this week.
Yeah, I was gonna say I see the cloud channel and those PR opens and merges are flying by for your team too. So it's been super productive week, which I don't know. It makes it hard to talk about stuff on the podcast or on the live stream because I feel I like it just flew by. Like I don't know what happened.
Yeah, I agree. I think it feels easier to bring up specific topics when we have slower weeks or like deliver less. So I feel like I need to get better about like tagging things as they go
Oh,
by during
interesting.
the week. But I do back to your point about stuff flying through the Slack channels. I do feel like it's a good sign when at our like engineering retrospective that we have every sprint and Mike and I had with the team earlier today. One of the key topics of discussion was like, we're gonna have to move these notifications to a different channel because we're we're shipping too much
Yeah.
stuff too fast. So,
Yeah.
um,
And then the GitHub limit we hit yesterday. So I went to open an issue on we use GitHub projects for tracking our sprints, and it denied me adding an issue to our project because we hit our 1200 issue limit on our project, which is just some hard limit that's on everyone's thing and you can't circumvent it.
yeah, that was really interesting. And you know what I thought? I thought to myself that, oh well, for context, for folks watching or listening, we were on Jira for a period of time, and then we switched to GitHub for all work planning essentially. And I thought, oh well, I bet we just have a bunch of those old Jira issues that I'll go and clean out. And I was like, oh no, actually, we've cleaned out a lot of those, and these are all like things that we've been opening and completing and that sort of thing. So it's definitely good slash
Yeah.
bad to see, I guess. We came up with a
Well,
solution. So
and it does really feel like we have like alignment across the engineering team on like what we're working on. So like everyone's generating their own things of stuff that we need to do, and like all those are getting picked up and worked on. Like it's a really good like machine we have going on this week or this last sprint at least.
yeah, absolutely. I definitely think that creating a good system for folks to be able to create their own work items while still having it like roll up to a cohesive vision or plan for a quarter, a year, whatever, does feel like kind of like the sweet spot for engineering velocity.
Yeah. So it's been good. I like it because I can't keep my mind on what I want to be on unless I have it like laid out in front of me. So it's good. I think I told you that too for the stand-ups channel in Slack. Like I don't
Mhm.
care if anybody else is looking at my stand-ups. I'm using it as my to-do list.
Right, right. Yeah, no, I think that is a good policy. When you said that, I realized that I kind of do the same as well, and also like a course correction kind of thing for myself when I like I always when I do my stand up for the day, I'll just copy my one from the day before
Mhm.
and move today to yesterday. And but sometimes I have to edit the today that I moved to yesterday because I'm like, oh, I didn't actually do that. Like why didn't I do this thing, or why did I do this other thing? Was that actually the right decision to change priority and bump something ahead of something else? So that's also helpful for me.
Yeah, like I copy mine as soon as I post it for the day and put it as a draft and delete the yesterday
Oh,
from it, and then I'll move stuff up as I do it.
oh wow, you're a level above me there. That's a good idea. I
It's
might steal that.
it is the most inefficient checklist
Yeah,
possible, but it's
yeah.
like that's the tool that I'm checking throughout the day anyway for like conversations and stuff. So it does make sense to like have stuff there. And then I think sometimes for reminders and stuff, I'll send a message to myself and then tell the bot to remind me about it in an hour or 3 hours or something.
Oh
So
right. Yeah, we've definitely embraced the I think I don't know, maybe this term has been deprecated, but chat ops or whatever
ooh,
is
chat ops, yeah.
does feel like our mode of operation. We're definitely heavy users of Slack and Slack webhooks and bots and whatnot. So seems like the right amount, though. I don't think we're overdoing it yet. Yeah. Well, cool. Well, given that we did ship a bunch of things this week, but it's hard to recall, was there anything that kind of stuck out as interesting to you that you wanted to highlight?
Well, I opened up the console and I was like, this looks different. And
Yeah.
so that stuff that we demoed last week is on production, and that stuff that you demoed last week is on production. And then I was definitely using the orgs navigation stuff, because we have a development server at a different URL, and we run some of our CI into that, but we're trying to move it all over to the production server. And then I have like orgs and projects that I demo for customers, and then I have an org and a project that I demo like at training, which we had on Wednesday. And so I was the one of the people that was like, hey, I can't find any of my stuff anymore, and I had zero problem this week. Like, it was
Awesome.
super. The most I ever had to do was like look into orgs, and I was like, oh, there it is. But most of the time, like, just having the list of the name of the orgs and then be able to hover on them was super helpful. I don't know
That's
if people are
awesome.
bored to tears by this UI talk, but I appreciate your work.
That's awesome to hear. I'm really excited to hear that. I know that was one of the it ended up being sort of a we try to break our work down into small units, but this PR, for a variety of reasons of the front end architecture, ended up being kind of a little more monolithic than I wanted. But it ended up closing like 5 or 6 issues in this one PR, and one of them was your issue you had opened about that. Although I do still think that it would be really nice. I don't know. I think folks have maybe varying opinions about when sites will have like shortcut keys. But I personally am a pretty big fan. You can do it on GitHub, I think in Notion as well. I think it would be really nice to be able to, like, like Control K, I think it might be on GitHub. I don't remember, but like Control K and just like type the first couple letters of your project and jump right there. I'd love
That
to get
would,
there one day.
yeah. Project search might be nice. Again, like, it's hard to judge how much of this stuff I'm using because I have unlimited account that I can make as many projects and everything as I want. And people who have like an actual production fleet that represents the real world, and maybe they're keeping it very few projects and very few like groups in order to keep it organized. So maybe, I mean, like, a project search to me makes a lot of sense, but I don't know if it's a priority.
Yeah, yeah. Well, I think the feedback that you and others internally give are is super helpful. And the other thing that is super helpful, which I will say, I was nervous slash excited, like good nervous for so the things we demoed on Friday, we deployed to production on Monday. And then we had training on Wednesday, and Mike leads our training, and it's one of like the things that Goliath is known for, our Zephyr training. And one of the things that's really great about that is we get, X number of users, some tens number of users, come in and exercise these various flows on our platform. And oftentimes, you can't predict all the way folks are going to navigate and move through and that sort of thing. So I was excited for folks to come in and use the console with the changes and the different navigation updates. We did catch one small bug that thankfully didn't impact anyone in the training, but another internal person, Chris Wilson, caught it, and we got it fixed real quick. But
Yeah, I saw that one go by. That was a great turnaround. It's
yeah,
amazing,
yeah, yeah.
Cam.
I knew. Well, so the thing was, it was in like that org project switching structure. The when you update or when you create a new organization or a new project, right, we obviously need to refresh that list for the next time you see it, or if it's already open, we need to reload it or something like that. And I had caught that before, the different way we were doing orgs and projects, we weren't refreshing the org in a certain situation where you created a new one.
Mhm.
And so I'd caught that, and so immediately when he said he couldn't find the project listed under the org, I knew that it was the same issue for the project, and I was like, oh, I caught it in one place, but not the other. So it was great to get that feedback and get things turned around. And
Yeah. Well, we
yeah,
totally want to hear from people. So if you're watching and you have anything like, boy, this is weird, I wish we had a dark mode. That's my
yeah,
next or anything at all. we want to make the product better, and we can only do it if people tell us. So forum.goliath.io is a great place to go, or you can email devrel@goliath.io. Any way you want to reach out, we're happy to talk to you, and we will definitely respond to feedback.
Yeah, absolutely, absolutely. It's also free to use the lower tiers of Goliath. So jump in there, try it out. You don't have to have any hardware. You can use our simulator. Now we've just turned into a commercial here, but but you should try it. So
we have a thing, use it.
Yeah, exactly. If you want us to keep showing up here every Friday, then we need to keep getting paid. So jump into our console. Awesome. Yeah. Anything else related to training or anything like that? I'm actually going to close my video here for just a second and just put you front and center because I want to adjust my lighting. But
okay. Yeah. And I think you're getting ready for a soon to be demo as well, right?
Yes.
Yeah. Okay. I'm excited about that. So, like you said, training was on Wednesday and went super well with that new code spaces. It's a little, we switch virtualization platforms. It's a little like nerve wracking because you don't know if it's going to work well or if it's going to be an issue, but it didn't seem like people had problems, and it maybe seemed to be more responsive, especially for people that weren't close to the virtualization server we used to have, since I think it was like in California. And so if you were like in Europe, it might be a little laggy there. But going to code spaces, it's like there's regional locations for it. The other thing, I don't think I'm letting anything out of the bag. I mean, if people are savvy enough to watch this show for information, they're savvy enough to watch our firmware SDK and realize that we are getting close to a release. Like I should look at the commits and merges, because I bet it's just going like that. But so we are planning to switch over the training code to the Golioth firmware SDK for February. And that'll be the first training that we do on that SDK, which it won't impact training a lot. The code base will be different. We don't do a ton of API calls, but we are planning to tweak training to a more like Golioth centered, to have a module that's more centered on Golioth. So it's like, okay, you have a sensor doing this sort of thing, and you need to send it to the cloud, and here's how you do that, and kind of like get a way to step through those API calls. So I am kind of excited about February training. And let's see, what is the URL for that training sign up? Do you know?
Oh, I know it updates automatically.
Yeah, it's like training sign up.
Let's see if it's.
I think Ariana was just saying that we should put a link on the front page of the. Yeah, so it's training sign up, and I'll post that here. So join us for that training and let us know how it goes, because we do want your feedback, and that will also be we'll spend some time introducing the API calls that have been a little bit different prior to this, going into the, on the Zephyr SDK, going into the firmware SDK, which is going to be generally available soon.
All right. Yeah, I was, I think we talked a little bit about the code spaces, the change from Chasm to code spaces last week. But it seemed like that went off without a hitch. So that's really awesome. And I know, I think maybe some connections at GitHub, or we're pleased to see that perhaps as well. So,
oh, cool.
I'm sure they will. Cool. Well, the other thing, that you mentioned, it's going to be sort of a demo, I guess. Unfortunately, I don't have the privilege of showing off some of our code internally, because it's not all open source, even though our awesome firmware SDK is. But I was going to talk a little bit about something that has been an internal project for pretty good period of time right now, and kind of like peel back the curtain a little bit and talk about both the rationale for building it, what it's currently doing in our architecture, and kind of like where we see it going. And so I'll pull up my for anyone who's worked with me, that I'm a huge fan of Excalidraw. If you've never used it, it is just about my my favorite thing.
You're super agile at it too. I'm always impressed by how quickly you get the tools you want, and like it doesn't slow down your thought process.
Yeah, well, I think it's from that might actually be a hindrance in a way of me recommending it to other folks and just assuming that they've also spent hundreds of hours in it. But it does allow you to go really quickly, which I like because it kind of takes this philosophy of your drawing isn't going to be perfect, so let's just start with that assumption, which I think is really nice. But anyway, the thing that we're going to talk about, and Mike, just kind of feel free to jump in here. I feel like I've been down in the weeds on this for an extended period of time, so there are things that I kind of like take for granted or obvious that I'll skip over. So feel free to just jump in and ask away at anything. But the name of this thing is the Constrained Device Gateway, or CDG is what we refer to it usually as. So, why the name Constrained Device Gateway? Well, it's kind of descriptive. It is essentially an API gateway, which for folks who aren't super familiar with API gateways, it's a bit of a nebulous term, but essentially is a service that sits in front of a bunch of other services, kind of like a reverse proxy, or it really is a reverse proxy, but it may have some other capabilities beyond just shoveling like L4, L3 traffic around. So it's a gateway that sits in front of a bunch of our device services. And it specifically focus on constrained devices because that's mostly the category that we're working in. And constrained devices are introduce a set of problems that we're trying to address with this piece of technology. So that's why we felt it was important to include in the name. So couple of things, and I'll name a couple, and Mike, you probably have maybe some that are top of mind from your hardware and firmware experience, but things that make constrained devices difficult is one, they are potentially power constrained, which means that you want to really optimize their network operations, which some of that is, writing your firmware in the correct way and leveraging accelerators and things like that on the device, but it's also managing that connection and making sure you're not forcing the device to do extra work from the server side. So that's definitely a big one. Another thing about constrained devices is they're frequently not available, right? You're not on all the time because you're either power constrained or network constrained or any other set of constraints. And so you have to build a system that assumes that many of the requests or interactions are going to fail or not be possible at a given point in time. So those are really
Yeah.
big ones from the server side. Do any come to mind from the firmware side for you, Mike?
Well, I think the big deal is that like early Internet of Things stuff was treated like servers on
Mm,
the internet. And
mhm.
like you really can't do a lot of good hardware things if you're treating it like it's in a server rack with unlimited power and cooling and a huge amount of RAM and compute power. And so just kind of being smart about how using the cloud for the good things that the cloud is, and having consideration, like you said, for like battery or like a device that doesn't have a ton of crypto acceleration in it. And maybe if you put a large burden on its encryption every time you communicate with it, that will drain your battery down and also makes for very slow communications, which means more radio on time. And yeah, I think these things stack on top of each other. But even more so, like being aware that we don't know what the constrained devices are going to be needed to do, and so having that in mind, that we want to make it so it's easy to pare down your device, but also easy to do whatever you need to.
Yeah, absolutely. That's a really good point. I like that you described the early IoT devices as being treated kind of like servers because it leads into the kind of the other side, maybe from like my more cloud perspective, is one of the things that I noticed is a bunch of the services we were building, which yes, we're interacting with devices, but more or less are like cloud microservices essentially. We were having to make a lot of concessions in how we were architecting them to accommodate for this interaction that we were trying to manage with devices that had certain attributes. And that one was just kind of like cumbersome and led to some kind of like technical debt and that sort of thing. It too is just more cognitive overhead. There's a lot of frameworks and support for building things in a cloud context that may not be applicable to working with constrained devices. And three, also like, we're still a pretty small team here, but when you're bringing new folks on board, if they have to really bring all this context into head or understand how to interact with these devices or what their properties are like, that's definitely going to decrease their velocity. So both the device side, which has certain attributes, on the cloud side, we really want to, like, in both domains, really like lean into common best practices, widely available technology in those places. And it felt like we were kind of in the middle, right? We were like on both sides, we were trying to like get a little bit closer to the other, and that was kind of having a negative effect in both places. So I think that's a really good call out. Kind of like maybe giving an idea of some of the services, and this is more of a conceptual diagram rather than a technical diagram here. But we have, a couple of services up here. So let's say something like OTA. We have logs. We have settings, and a couple of other ones. Actually, one that I'll pull in here because I think it's interesting, maybe to be like kind of a representative sample of types of services, is we have our RPC service. So, like I said before, CDG kind of sits here in front of these, and it has devices on one side, and then what we call services on the other. So you'll have some number of devices over here, and on each side of CDG, we have a concept of sockets. So these are based on Unix sockets, but don't interact necessarily the exact same way. But you can imagine that there's basically endpoints here on either side of CDG that support a certain protocol, and they're either device facing or service facing is the way we refer to them. So this doesn't actually have to match exactly. Let's actually make it not to illustrate more clearly. So on the device facing side, a lot of folks are familiar with the fact that we use CoAP. So we may be communicating with a device via CoAP. So let's say we're doing that, or CoAP S for secure CoAP. So we're using DTLS. So that's currently how most, if not all, of our devices are communicating with the platform. Now, for each of these services here, in the past, we had to write CoAP servers, right? They had to be able to communicate with devices. They had to authenticate the devices. The support, this may not come as a shock for folks, but the support for CoAP frameworks and libraries is much less than HTTP and a variety of other common protocols. And so while we have been able to leverage some really great frameworks on that side, it was somewhat of a pain when we wanted to reach for patterns or mechanisms that we're familiar with from writing HTTP or gRPC services or something like that, and they're just not available to us. And there's a lot of investment to make that work. The other part of that is if we want to add support for another protocol, let's say we want to have devices also be able to communicate via HTTP. It was not adding support for HTTP once, right? It was going through all of these different services and having to implement HTTP handlers for many of them. Now, CoAP and HTTP are maybe even the simplest case of this because they map very closely to one another. But it still is, it's a O of N operation instead of an O of 1 operation there. So that is obviously not ideal. And as we continue to grow in our platform, that was only going to become more painful as N increased. So that was kind of like some of the basic ideas around that. So internally, what CoAP does, or what CDG does, is it basically takes information from a message, is how we refer to them, from a device. Let's just say it's a device-initiated interaction here, and it converts it to an intermediate representation or an IR. So we have something called the CDG IR here. And the purpose of doing this, you may be familiar with maybe like LLVM or some compiler frameworks that use intermediate representations, which the name is once again descriptive. It's an intermediate representation that sits between two other things. And the purpose for that is having a common language to translate through. So what we're trying to do here is basically take messages across a number of different protocols going in a number of different directions, package them into an intermediate representation, and then send them somewhere else. But once they get to that IR, we don't care about where they came from or where they're going anymore. It's portable across all of them.
I heard you like APIs in your APIs, yo.
Yeah, right. Exactly. So so we get it to this intermediate representation, and then we also have, and middleware is not a new thing, right? We're not reinventing the wheel here. We just kind of optimize it for this one use case. But also in between our device facing and service facing sockets here, we have what are called augmenters. So they basically also operate on intermediate representation. So they may do something like implement some sort of rate limiting, or they might implement some sort of authentication, for example, that happens in the middle. And what they also allow you to do is say, maybe I want to augment this message. That's where the name comes from, before it gets passed along to another service, for example, which I'll just kind of like to complete the picture here. Let's say we're talking gRPC to the OTA service here. I might want to augment this message, let's say inject a timestamp into it or something like that before I send it along. What they can also do is short circuit the message, though. So in the case of like rate limiting or authentication or something like that, you may want to say, oh, some attribute of this message or its associated metadata is leading me to actually not send it along to whatever destination. You also can implement things like routing. So there's attributes on this intermediate representation that help CDG decide, hey, which socket is this supposed to go to? It's not just hard coded that, the CoAP socket is mapped to the gRPC one. Once it gets to intermediate representation, you can route based on attributes of that message.
Can you route based on like custom things too? Like, so if we had a customer come in who said, I don't want to use the shared servers, I want them to go to dedicated servers, is CGG up to that task?
It is. It's some of the augmenters are mostly optimized for internal use right now, but to kind of like without getting too far into the weeds, you can imagine that this IR looks something like there's some data that is intended to be sent as part of this interaction, and then there's a bunch of kind of like attributes that are associated with that data, and they have unique keys that map things like think about the like headers in a protocol is a good way to think about things that might be mapped to IR attributes. So like the method or a status code, or maybe some authentication information. So what we allow you to do right now, the routing augmenter, there's a augmenter called route that basically says, hey, give me a list of conditions here, and it allows you to specify arbitrary keys. So we have a list of basically keys of IR attributes, and you can say, if, evaluate this key for the value on that key. If it matches this value, then route it to this location. So the most common one is most protocols have some concept of a path that they are, appending to the domain that CDG is running at. And so, for example, that gets translated to an attribute on the IR. And so doing path-based routing, which is, perhaps the most common case of routing, it's just a generic route augmenter that says, I'm going to map on the path attribute, match this condition for whatever the path is. And right now, it's a constrained match, but it could be something like a regex or something like that. And then say, this is the destination socket. And you can actually do that going in both directions as well. So it's not just device to service, it can also be service to device that does some routing there. One, and maybe that's actually a good point to say, is like our RPC service here is unique because it will initiate a connection. So it's not all just like request, round trip response back. And this was another thing that became really cumbersome with our previous architecture is device or service initiated interactions, or we might even say user initiated interactions. with a service, because with RPC, for example, you go into the console or you call our REST API and say, hey, call this function on a device on its firmware. And those were difficult to deal with because you had to have some connection information about how to talk to that device. And devices can act as co-app servers, or some other protocols also allow for devices to act as a server. But that's not traditionally how we've done it, and there are some drawbacks with having it act as a server. And so what we do is leverage a concept called observations, which we basically say, here's a path. I want to be notified of updates on it. And you can use that mechanism to essentially do service initiated requests as well. But what you need to do is say, if the user is going to initiate an RPC here, we need to look and see if the device is willing to answer that RPC, basically by establishing a watch on it. And every place that we implemented that, if the devices were talking directly to a service, that was a big problem, right? Because we didn't know where they had established observations or not. So with a new architecture here with CDG, it basically can establish an observation. I know we're talking very specifically co-app, but that's the most common case here. You can establish an observation on a path, and then the RPC service, it actually is more like, instead of having this kind of like bidirectional interaction where it's trying to understand what's watching, it has two ways to interact with CDG. One is maybe it's answering some requests and response that are normal, or we have a publish and subscribe mechanism here where any service basically just has a publish method where they can send a message to it with a device identifier and say, hey, I want to publish this. I want to send something to this device, but I don't really know anything about it, and I don't want to have to deal with managing it or anything like that. So it just sends it, and then CDG will subscribe to those messages that are coming from services and evaluate, hey, this is possible or this is not here because this device is online or it's not, or it's established an observation or not. And it will handle actually dispatching that to the device. And then if the device responds to it, forwarding that along to the RPC service. So you can see how that kind of interaction works here.
So it kind of abstracts like available communication types instead of specific services.
Exactly. And I think that the service, it's kind of similar to like server sent events or something like that in a web context. But that model of communicating with devices in a service initiated way that's based on a request from a device is just not a real common model for a lot of cloud APIs. And so kind of abstracting that away where the services can just say, like, I can talk to any device at any time and I don't have to worry about state management or anything like that, makes it a lot easier to author new services, which is really important, especially when we have new use cases from a customer. If we're able to turn those around really quickly, that obviously, increases our value quite a bit. So yeah, this is most of the the other thing I wanted to mention is how this is in use today. So a lot of our we run systems simultaneously as a migration kind of path. So a lot of our traffic still goes through our old architecture, which is okay, but not for long. And the way we actually rolled this out is, folks may have, I think a few weeks ago, we chatted about our first stream in the new year. There's also a blog post that went out about it, but we introduced this simulator in the Golioth console here. And so basically the simulator talks over HTTP because it's in the browser, and all of its traffic goes through CDG, and it actually talks to our stream service. So in that case, we were able to deploy CDG in front of our existing co-app services. So let me get rid of this for a moment and imagine that, we just had a LightDB stream service here that devices did and still do talk to directly over co-app. that CoAP endpoint is still present here. So a device could be down here talking to it directly over CoAP, but our simulator talks to it um, uh, via HTTP, but CDG translates that to CoAP. So it allowed us to kind of stand this up in front of our existing services to add new protocol support. So that was a really cool kind of first use case because it was low stakes, you might say, in a way, as the simulator is meant to allow you to simulate things, but it's typically not your mission critical data. So it was a nice way to roll it out. And also it was a nice way to add HTTP support actually for all of our services by just adding it in this one component. So that was pretty neat to get out there.
So if all of our services were made initially to talk to the devices, was it an arduous process to convert them to talk to CDG, or once you got going, was it straightforward?
Well, the nice thing, it was pretty straightforward. Part of that is because of the similarity between CoAP and HTTP, and also gRPC, which we use gRPC and HTTP in a number of different places and use some translation between them. So it's not too difficult. But the thing that made it very easy is that we could do it incrementally because of like LightDB Stream here. We could have components that we're talking to LightDB Stream through CDG and some that we're talking to it directly. So as long as we preserved that CoAP support, we could do this incrementally along the way, which is really nice. At a future point, we are planning on not exposing CoAP except for through CDG, or having all traffic go through CDG, which has a number of also benefits around once you have a single point there. You can collect metrics there. You can do a lot of instrumentation that you don't have to do in different services. You may still, obviously want metrics and things like that at those services, but some of the kind of like system level metrics you can initiate from CDG, like if you want to do spans or traces throughout a system or something like that. The other thing is scalability was really difficult with our kind of like dedicated services because of that need to maintain state. So with CDG, the goal is to kind of be able to run multiple instances of it and horizontally scale it out while still maintaining that long-lived connections. And we can do that via external caches and things like that. But we don't have to worry about implementing that once again for all of our services and trying to horizontally scale them. They can easily be horizontally scaled because they're just talked to over HTTP via CDG, so we can put a load balancer in front of them or anything like that.
I might have to go grab this dog. She's barking. We have a dog who's deaf, so she can't hear herself barking. But let me know if it's really bad.
It's not. It's not too bad.
The thing that I think about with this is like when we talked about device ID, CID, what CID, right?
Yep. Connection ID.
Sorry, connection ID. There we go. When we're talking about connection ID, is like, again, for the end user, like you're not going to really see any of this. Like the result is like easier for us to add more things and better performance, especially at scale. But the actual like day to day of how the devices get data to your dashboard or to your REST API calls or to whatever end service you want really won't be seen, right?
Right, exactly. Hopefully, the number one thing that users see is just we're delivering a lot more features a lot faster.
Yeah, absolutely. And well, we know there's some more exciting stuff coming too.
Yes. Some features. It turns out we are going to introduce some features. Yeah.
There may be a new number of amazing features coming.
Yeah, we're very excited about this quarter specifically at Goliath. So we'll have lots more demos on the stream. Any other questions that kind of came up about this architecture, or anything maybe not from what I talked about today that you've been wondering about it, Mike?
Well, I think the C connection ID is still in my mind, and I really appreciate that time that you just jumped on a call, and, like took me through like with Wireshark and everything. You showed me how it worked. Like it's a really cool system, but like CDG, does that facilitate connection ID, or is it like separate from that?
So we introduced Connection ID, which is a extension of DTLS, into our old architecture. It's also supported in CDG. Actually, supporting it in our old architecture was updating a dependency version and flipping a flag. Really, all the work went into a bunch of open source libraries that we depend on. So we could easily consume that work as well in CDG, which was really nice. But the thing that connection ID enables is some of these longer lived connections when your IP address and port are changing, which once again, talking about constrained devices, they may be in motion, they may be going to sleep, and every time they wake up, they get a new IP address assigned or something like that. The connection ID allows you to maintain that connection. Well, if you have, a bunch of these different services, that scalability question comes into mind, because in order to maintain that connection over a long period of time, the server also needs to not be restarted or have an external store for that connection state as well. So CDG implements the exact same thing from a protocol perspective as our previous architecture, but it is implemented in a way that we can also store the connection IDs in a more persistent location that can be leveraged across multiple instances running. So it does help, enables using this connection ID more effectively and over longer periods of time.
And then I think in the more abstract areas, so like to me, the nice thing about CDG is you maintain an encrypted connection with one set of keys between the device and the server. And then a lot of things can happen that the server makes sure is secure. If I wanted, like, if right now, if I want to do something like I want to get NTP, that NTP call is outside of the connection to Goliath. So like you're responsible for doing that. And I just said NTP because I'm thinking of something that maybe I would have used in the past. Is there potential for to go through CoAP to the CDG and get things that aren't these services that are currently available?
Yeah. So there could, be in the simplest case, I guess, is we introduce a new service. There's also, because it is, essentially a reverse proxy, there could be ability to flexibly add and do dynamic routing of new services based on the devices that are talking to it. So that's something that could be in the future. Another aspect of this is CDG is implemented in a way and intended to be able to be kind of like chained together. So there's nothing really saying that, maybe just for illustration purposes, I'll just do it this way. There's nothing saying that this service here isn't another instance of CDG.
Oh,
and
interesting.
yeah, so for example, here we're talking about having HTTP and CoAP. An instance of CDG here could just be like an HTTP to HTTP to, some other services over here. And this is really interesting architecture when you think about wanting to do edge caching, or you need some data to be kind of constrained to a certain geography or something like that. So that's another way where, let's say this is the Golioth platform CDG here. If an instance of CDG exists somewhere over here, potentially not running in Golioth, but able to communicate to Goliath's, gateway endpoint.
Yeah.
You could ostensibly have, some of this going off to some other location over here where you don't want that data to come to Goliath. So,
Right.
yeah.
Because it seems
Now we're
like,
getting
one
into
of the,
very
yeah.
future.
Well, I mean, the thing is, one of the things that we replace is like the messy part of this, managing devices and routing data, right? So like to me, relatively, it's not too hard to stand up a platform that has the things that you know about right now and are very tightly specified. But then once you have that and you're using it and then you need other stuff, it becomes really difficult. So like looking at this and seeing that there's this framework that we already have that's planned to make it so we can get things we don't even know about that customers need yet put into place quickly without the devices needing to change and without needing to re-architect every service. It does obviously make a lot of sense, and so I'm excited about the rollout for this.
Yeah, well, I'm glad to hear that, and I'm very excited as well. And I think that one of the things you called out there is, the idea for this I'm newer to the IoT market, I guess, if you will. And one of the things that was immediately obvious to me when I was researching the market before joining Goliath and then after joining Goliath was how heterogeneous the solutions are and the architectures. Um, Whereas, there's differences between architectures in the cloud as well, but there's a lot more kind of like reference best practices. And there are those in IoT. There's also just a lot of maybe poorly designed architectures or insecure architectures, which we're trying to help eliminate as many of those as possible. But it was really clear that different use cases, where a device is going to be deployed, how often it's going to be in motion, what access to power it's going to have, was just going to create this like large swath of use cases that, our value prop is that we basically will work with any hardware in any scenario almost. And so if we we're going to do that, having kind of like a modular architecture that we could easily add new capabilities to, or layer capabilities in the case you have multiple CDGs, was kind of felt like the only option in order to be able to accommodate that. So hopefully it's successful in that goal. I think so far it's been working quite well. So we're going to continue to lean more heavily on it, I think. Yeah. Cool. Well, that is as much of the demo as I'm going to be able to give without Jonathan pinging me and saying, "Hey, stop selling company secrets."
That was a good one. I liked it. Yeah.
Awesome. Well, if folks like the kind of like whiteboarding sessions, Mike and I definitely like them a lot. And I think there's some other things I'd actually really like. Some of the firmware updates in the cross-platform SDK. I'd love a similar whiteboarding session on some of those. So if folks like this, I'm sure we can do more of these in the future.
Yeah, I think we should do some live coding sessions too. It might be fun to like start from nothing and stand up some devices to just do various stuff to like kind of show how we work through it. I know when I see other people do it, I always appreciate that. And I don't think I'm going to make it to ZDS this year, but from that first ZDS I went to in 2022, I've always thought that they should have the maintainers of Zephyr RTOS doing like in the lunch area with a projector on a wall, just doing like, here's how I work with this module in Zephyr, and just kind of like seeing from the people that use it most. I think that's really useful.
Yeah, absolutely. One of the other things I've seen that I think is really cool is I've seen this mostly, I'm not necessarily with companies. I have seen it with some, but like with individual streamers, that they'll like put out a poll at the beginning of the week, and it's like, here's 4 options. Vote for the thing you want us to build in 30 minutes or something like that. And one of the things we really pride ourselves on, I think, at Goliath is the ability to get started and get up and running with Goliath really quickly. And not only on the device side, which I think is the most common, but also on like consuming data and building cloud services on top of it. I know you and I obviously had a lot of fun kind of marrying those two components together at SuperCon this past year. And I think like even seeing like, how fast, maybe even put like a timer in the corner of the screen and see how fast we can build something that folks suggest on social media could be a lot of fun. So we might have to try that out. That sounds like a lot of fun. Cool. Well, maybe we'll iterate on some of these ideas. So make sure to stay tuned for the Goliath accounts, and if we have a poll, we'll put it out on there for sure. But yeah, if you don't have anything else, Mike, I think we can go ahead and wrap it up here.
Yeah, it was a good one this week, Dan. Thanks for having me on again. It's good to see you.
Awesome. Of course. Have a great weekend. And to all of our listeners, have a great weekend as well.